Alright, these are the 1-3 notes manipulating formulas. Objectives: you'll be able to manipulate equations using inverse operations. So the problem style that we're going to be doing looks like this. It says if a is a non-zero real number and a parentheses x plus 7 squared plus d equals e, prove that x equals plus or minus the square root of e minus d over a, then minus 7. You gotta show all your work. So kind of what they're asking is solve this equation, solve for the variable x in this case. And then there's gonna be a part B. If a equals 6 and d equals 10, determine the conditions on which e will restrict the solutions for x to real numbers. And explain your reasoning. And you're gonna enter your proof. So in other words, you just have to show all your steps and show every single bit of your work. That's what they ask for as far as proof. These problems are similar to what we have done in class. The presentation is just a little bit different. So let's take that problem. A times x plus 7 squared plus d equals e. Here's all my work for it. Pretty much I'm going to revise the directions just to say solve for x, because that's all really what we're doing here to prove it. First, this is what we're given. Next is the subtraction property. And you're going to subtract d from each side. So we get a times x plus 7 squared. We're going to equals e minus d. Because e and d are not like terms, that's why I write e minus d. Next, we're going to then divide by a using the division property. So we divide by a to both sides. So the times a and divide by a, they cancel out. So we get x plus 7 squared is equal to e minus d divided by a. To get rid of that squared property, we do the square root. So we take the square root of both sides. Square root and squared, they cancel each other out. So we get x plus 7. And that's equal to SQRT, which stands for square root of this entire thing. Then to get the x by itself, I subtract 7 from both sides, and I get x equals square root, parentheses, e minus d, close parentheses, divided by a, close parentheses, minus 7. And that's our solution. All of this will be the solution. That's what you need to write the entire thing in the box there. Alright, number 2. This is what the problem will look like. Our goal is to solve for x again, prove that x is equal to plus or minus the square root of plus e minus m over r plus 4. Show all your work, meaning show all your details. Here's all my details here. So directions solve for x. This is what you're given. I want to get x by itself, so I do all my inverse operations. The opposite of plus m is subtract m from both sides. That's why I get r parentheses x minus 4 squared is equal to e minus m. That r times the opposite of times r is divide by r. That's why I divide by r to both sides. And I get parentheses x minus 4 squared is equal to parentheses e minus m close parentheses divide by r. To get rid of the squared, I do square root to both sides. So the squared and the square root, they cancel out, so you get x minus 4 is equal to square root, which is plus or minus, parentheses, parentheses, e minus m, close parentheses, divide by r, close parentheses. Then move that minus 4 to the other side, I add 4 to both sides, and I get x equals plus or minus the square root of parentheses, parentheses, e minus m, close parentheses, divide by 4, close parentheses, plus 4. That's how I get that answer. Here's another one. If a is a non-zero number, real number, and a, got that equation, prove that a is equal to this equation, show all your work. So we plug it in. Directions pretty much say solve for a. And we're going to write the whole proof out. So given a is all this, I subtract n from both sides to get this. Remember, our goal is to get a all by itself. Oops. They are asking for a to get by itself. Okay. So I gotta take this. Our goal is to get a by itself, not q, like I just did. So this one's actually a little easier. Since we have a times q minus 4 squared, all we got to do the opposite of times a is divide by a. So we're going to divide by a to both sides. Sorry, not divide by a to both sides. We're going to divide by q minus 4 squared to both sides. Because a times this, and our goal is to get a by itself. So we're going to divide by q minus 4 squared to both sides. So our final answer is going to be a equals b minus n over parentheses q minus 4 squared. And that'll be our solution. So we didn't do the additive property, and we didn't do the square root property. So it's a little bit quicker, this one. Here's number 4. Our goal is to solve for b. So that's what I did here. There's your problem. I subtract n from both sides, so I get b parentheses, so on and so forth. To get b by itself, since it's b times, I have to divide by the s minus 6 squared to both sides. So I get b equals y minus n parentheses, division, parentheses s minus 6 close parentheses squared. Here's another one. Why don't you try this one on your own? Here's your equation up here. Your goal is to solve for b using your inverse operations, so you get that. Here's the work. Solve for b. So I subtract n from both sides. I divide by s minus 8 squared to both sides. So I get b equals p minus n, division sign, s minus 8 squared in the denominator. Here's your classwork and your homework. If you have any questions, feel free to email me or come next drop. I'll be happy to do a couple more with you. All right, have yourself a nice night.